Hello! Today we're going to be graphing linear equations. So I have the equation y equals 4x minus 1. Now we know it's linear because they're all to the first power. I'm not multiplying variables together. I'm not square rooting anything, etc., etc. Okay, so if I wanted to graph this, let's do this first by just making an xy chart. So I'm going to make an xy chart here. Okay, so let's pick some numbers to plug in for x. So let's start with -1, and we'll go to 0. We'll try 1 as well, and we'll see where that gets us. So if I do -1 first, if I plug -1 in, my y is equal to 4 times -1 minus 1. Well, 4 times -1 is -4, minus 1 more is -5. So I have the ordered pair, -1, comma, -5. There it is. All right, let's plug 0 in. If I do 4 times 0 minus 1, well, 4 times 0 is 0. Minus 1 is -1, so we have 0, -1. 0, -1, there it is. Okay, all right, and so let's try 1. So 4 times 1 minus 1. 4 times 1 is 4, minus 1 is 3. 1 comma 3 up here. So you can see where the line is going to be positioned right there. Okay, let's talk about the slope of this thing. So if I go up and then over, I'm just doing my delta y over delta x. Remember, change in y over change in x. Let's make those real triangles. So my rise is 4, my run is 1. So I had a change in my y's, I went up 4. Then I had a change in my x's, I went over a positive 1. So my slope, m, is 4. Okay, if I tried it again, if I go up here, there's 4, I go over 1. Okay, if I tried it again, I go up 4 and over 1. And I should have, if I had drawn this right, another point right here. So here's sort of what this was supposed to look like if I come up like that instead. Okay, so now we know what the slope is. It's 4, and I want to point out something to you here, that the slope of 4 is sitting right there in front of the x. Now when we did our direct variation equations, we realized that the constant of variation and the slope were the same thing, both in front of x. And so they are, again, just in front of x. So now if I know the slope, graphing these should be easy. I only need one point. And what's the easiest point to find? Well, how about this right here, when you plug in 0? It's nothing more than making it go away, and so this is the ordered pair right there. When x is 0 and we get a y of -1, this point right here is called the y-intercept, if you remember. Right? It's where we cross the y-axis. So in this case, what we're going to do is refer to our y-intercept as b. So b is going to be, in this case, -1, the y-intercept. And that number, well, don't you know, it's right there. If I were to get rid of, if I were to make x 0, this 4x would go away. And so all you have left is y equals -1 when x is 0. So that number at the very end, that is your b, your y-intercept. So something to point out here, let me erase that. There we go. All right, so something to point out here, the equation for a line that is easily graphed. You start with y equals, your slope is being multiplied by x, and then you are adding on at the end your y-intercept. So that is your slope, and that is your y-intercept. Okay, now I want to remind you that x and y, those are variables. They are varying, they have to change. Whereas the slope and y-intercept, they don't have to change. These are constants. They are always the same. They do not change at all. They are constantly the same number throughout this problem. So let's use this information, and we will try to graph here. Now notice that this looks a little different than what we had before, and we want it to be y equals mx plus b. Because when it's in this form, I can pick out, again, the slope and the y-intercept. All right? So what is the key feature of this that allows us to find the slope and the y-intercept? Well, y must be alone. Okay, that's the big thing here. So let's use this over here, this information, and let's get y alone. So there's my y. I want to get it by itself. Imagine it locked there. We want to move everything away from it. What's happening to y? Well, we're multiplying the 3, and we're also adding 2x. So let's get rid of that. Let's get rid of all of those things that are happening to y. And we'll go in reverse order of the order of operations. So let's start by subtracting 2x, and I'll do that on both sides. So these cancel, and 3y is equal to 9 and negative 2x, not like terms. So we have a negative 2x, and we add 9. Then we're still yet to get y alone. We have to divide by 3. And when I divide by 3, that means I divide everything by 3, both sides. And dividing both sides by 3 means that 3 has to divide by negative 2x and 9. So what do we come up with? Well, these cancel, so y is equal to, we have negative 2/3 x plus 3. So that's great. Y is by itself. So let's label what we know. My slope, m, that's always the number here in front of x. So there it is in front of x, so my slope is negative 2/3. My b, the number here at the end, that's what's being added to x, so my b is 3. And we should be able to use that to graph this line. B, the y-intercept. Well, here's my y-axis, so I need to go to 3 on the y-axis, and there's the positive 3 right there. And from there, I want to do a slope of negative 2/3. I'll remind you that this is your delta y, and that this is your delta x. So let's change our y by negative 2, so we count down 1, 2, and then we change our x by positive 3, and there it is. There's our next point. And I can do that again. I can count down 1, 2, and over 1, 2, 3, and there's my next point. I could also go the opposite direction, because if you think that negative 2/3, it should be the same as 2 divided by negative 3, right? That fraction bar means division, and when you take a positive divided by a negative, you get the same thing. So I should also be able to go up 1, 2, and negative 3 over to find another point, and up 1, 2, and over 3 to the left for my next point. Okay, so you can see how we have the shape of a line. This is where it's positioned. We'll draw it in. And that's the graph for this line, and we are done.